Hello, welcome to this video. In this video, we will explain a neural network model and how it works. You would have been involved in using neural networks even without knowing you did, because some of the most used applications are based on neural networks, like facial recognition in our mobile phones to unlock them, social media apps that we use every day, Google Translate, which has saved many of us in foreign countries. Weather forecasts and CT scan machines are all some of the examples of neural networks. So this is what a neural network model looks like. Neural networks are made up of neurons, which are the network's core processing units, just like how our brain neurons are the basic building blocks of our brain. Here we have an input layer which receives the input, the output layer which predicts our final output, and in between we have hidden layers that perform most of the computations required by our network. One layer's neurons are connected to another layer's neurons through channels to communicate with each other. Each of these channels has a numerical value known as weight. These weights are random numbers that reflect how important an input is. Let's take an example to understand this better. Like the previous video, we have the same Titanic dataset here to predict the survival odds of passengers with neural network model. Our aim is for you to understand the difference between the two models. So now we will take this dataset and input these features to the input layer's neurons. For explanation's sake, we will take only 3 features. The input values are fed into the input layer and then it is multiplied by corresponding weights and their sum is sent as an input to the neurons in the hidden layer. Each of these neurons in the hidden layer is associated with a numerical value called the bias, a constant value that is then added to the input sum. This value is then passed through a threshold function called the activation function. It is activated if the function reaches a threshold value. This threshold value is a predefined numerical value. Now the activated neuron will transmit data to the neurons of the next layer. In this case, it is the output layer. But in the case of more hidden layers, the process repeats until it reaches the output layer. So the values of the output layers are just the probability of results. In this case, whether the passenger survived or did not survive. This is called forward propagation. During the model training process, the network and the input have output labels that state what output the neural network model should predict. If the model gets the correct output, as you can see here, the value of survived is greater than the other value. So the models predicted the passenger survived, which was the desired output. So the prediction is correct. However, if the input is wrong, the model shows a different prediction saying the passenger did not survive when it should have predicted survived. The prediction is said to be wrong. Then the predicted output is compared with the actual output to realize the prediction error. In this case, the actual output should be 1 for survived and 0 for did not survive. The negative error indicates the predicted value should be lower, while the positive error indicates that the predicted values should be higher. This information is then used to transfer backward through our network. This is called backpropagation. Using this information, the weights are adjusted accordingly to get the correct prediction. The forward and back propagation are iterative processes with multiple inputs until the network learns to predict the desired output. This is how the neural network model works and how the predictions are made. Thank you for watching this video. This video is followed by survey questions. Please do answer. Thank you.